Start with the title itself, Rational Exponents. We already know what an exponent is, right? So like, for example, 2 to the third power, the exponent is the 3, the base is 2, and the exponent tells you how many times to multiply the base with itself. So in other words, 2 times 2 times 2, which is 8. So we all know what an exponent is. How about the word rational? What does that mean? You guys remember from the beginning of the year when we classified numbers? Do you guys remember the comparison of a rational number compared to an irrational number? A rational number makes sense. An irrational number is pretty crazy. An irrational number would be like a decimal that goes on forever, that doesn't repeat, that has no pattern, kind of like pi. That's an irrational number. A rational number is something that totally makes sense, kind of like 1/2 or 3/4. As a matter of fact, inside the word rational lies the word ratio, and that's really a fraction, okay? So when we talk about rational exponents, we're talking about something like 9 to the 1/2 power. We're talking about fractions in the exponent position. Or maybe we should say exponents that are fractions, okay? And this is probably the last time we're going to refer to them as exponents that are fractions. We're just going to refer to them as rational exponents. So what's a rational exponent? This guy right here is a rational exponent. The power of 1/2, that's a rational exponent. Okay? So on this section, the main idea is to be able to convert a rational exponent into a radical, and also to be able to convert a radical back to a rational exponent. So let's first move this out of the way. And let's talk about what a radical is. A radical is any type of root. So for example, that is a radical. And we all should know what the square root of 9 is. What's the square root of 9? It's 3. Why? Because when you ask what square root of 9 is, you're really asking what number times itself will give you 9. By the way, in this little area, there's nothing, but technically you could put a little tiny 2 right there because that's the square root. But it's not necessary. You don't have to put the 2 right there. But we're also going to be dealing with cube roots. And right there you do need a 3 if you're talking about a cube root compared to a square root. Okay? So let's go back up to this one. Why is the square root of 9 3? Because 3 times 3 gives you 9, right? What is the cube root of 8? The cube root of 8 is actually what? Anybody? It's actually 2. Why? Because 2 times 2 times 2 equals 8. So you guys should understand the difference between a square root and a cube root. Now, what we want to be able to do in this section, like I mentioned before, is to be able to change a radical to a rational exponent, an exponent that has a fraction in it. Okay? So here's a good thing to jot down for notes. Let's say we have a radical. Right there, that's a square root, but let's just put an nth root right here. Let's put an n right there, okay? And what should I put on the inside? Give me anything. Let's just put the letter B, yeah? How's that? So that's a radical, and it could be the square root, could be the third root, could be the fourth root, fifth root, whatever. Depends what number's right here in place of n. But let me tell you this. This radical could be rewritten as the same exact number that's in there, in this case b, but as a rational exponent, it'll be to the 1 over n power. I mean, to the 1 over n as a power. Does that make sense? This is what matters right here, guys. This is the main course of today's meal. The nth root of something is really going to be that same something to the power of 1 over n. Let me repeat that once again. The nth root of something is going to be that same something that has a power of 1 over n. So, for example, let's say I had the square root of 9. We already know that the square root of 9 is 3, but if I wanted to write the square root of 9 as a rational exponent, that would become 9 to the power of 1 over whatever the root is, which is 2. So that'd be 9 to the 1/2 power. Okay? Now check this out. If you know that the square root of 9 is 3, you could actually take this 9 and rewrite it as 3 squared, and you still have to the power of 1/2. Now when you have a power to a power, what do you do? What do you do with the 2 and the 1/2? Multiply. What is 2 times half? It's 1. So you really end up with 3 to the 1, which is just 3, right? So we already know that the square root of 9 is equal to 3, but you could actually change the radical, change this radical to a rational exponent, and then you could manipulate the base so you could get some exponents out there, so you could multiply the exponents, and you could get your answer using exponents instead of using radicals. Okay? So once again, the main idea is to be able to change a radical to a rational exponent, and then also change a rational exponent back to a radical. So let's practice that. So for example, let's say I gave you the third root of a, and I want you to change it to a rational exponent. What will that become? A to the 1 over 3 power, right? A to the 1 over 3 power, okay? Let's say I had, let's say the fifth root of 8. I don't know, what would that be? That would be 8 to the 1/5 power. 8 to the 1/5 power, okay? So I hope we understand how to do these. Let's go, let's try something. Let's go backwards. What if I told you, let's say 3 to the 1/6 power, and I ask you to rewrite it as a radical? What would that be? That would be the 6th root of 3. The 6th root of 3. What if we had something like r to the 1/4 power? What would that be? That would be the 4th root of r. Does that make sense? Okay? So it's really as easy as understanding that whatever root you have, that's going to be the denominator of your exponent. The denominator of your exponent, that's a fraction. Okay, whatever root you have, that's going to be the denominator of the exponent of your fraction. And I might as well say this now, in Algebra 2, and maybe even later in this class, we're gonna refer to this as this. You're going to have the root, you're going to have the base, and a power. Okay? So when you have a radical like this that has a root, a base, and a power, then you could change it to the same base to the power over root. Same base to the power over root. Now I'm getting a little ahead of myself. Right now, all you need to know is that the nth root is really going to be the denominator of your exponent. The denominator of your exponent, where your numerator is 1. Okay? This is a picture taken from our book, and I don't even like the way they don't even explain. I mean, they tell you exactly what I told you, that b to the 1/2 power is really the square root of b, right? So they show you how to change it, right? So you have 16 to the 1/2, that's really the square root of 16, or 4, right? It would be nice if they showed you the manipulation of the base so you could see how the answer is also 4 without having to do a square root. So for example, 16 could be rewritten as 4 squared. So instead of 16 to the 1/2, you have 4 squared to the 1/2. And of course, a power to a power you multiply, so that's why your answer is 4 to the 1, which is just 4. I know square roots are easier, but it's always nice to see the manipulation of the base so you could simplify with exponents. So that's what they show on this page. 25 to the 1/2 power, that's really the square root of 25, which is 5. The square root of 18 You can't really get a nice answer for the square root of 18. You could simplify it, but we're not even doing that right now. But they do change it from the square root of 16 to 18 to the 1/2. And that's it. As you can see down here, the square root of 8p changes the 8p to the 1/2. Any square root is going to change to the power of 1/2 and backwards. Like on this one down here on the example, 7w in parentheses to the 1/2 power, that is the same thing as the square root of 7w. So jump into the homework assignment of today. The instructions say write each expression in radical form or write each radical in exponential form. Okay, so if you have a rational exponent, change it to a radical. If you have a radical, change it to a rational exponent. It doesn't even say simplify, so you don't really have to even worry about it. But so number one, we're going to change that to the square root of 8x. Done. Piece of cake. Number two, guys, what belongs inside the square root? What has the power of 1/2? The z only, right? The 6 actually has the power of 1. Okay, so the 6 actually has a power of 1 right there. So your answer should be this: 6 on the outside, square root of z on the inside. Make sense? Number 19, okay, change that. 19 to the 1/2 power. That's it. Moving on. Square root of 11, what do I change that to? 11 to 1/2 power. Piece of cake. And of course, you could be checking your answers as you go. All right. Number 5, a little bit trickier. That as a radical, what's the answer going to be? There you go. 19 square root of x. 19 on the outside. Again, because the only thing that has the square root is the x. The only thing that has the power of 1/2 is the x. Now, if you had parentheses around the 19x, yeah, then the whole thing would be inside the square root. But that's not the case here. Okay. How would you write number 9 as a rational exponent? Are you going to leave it like this? No, because that's only on the c, right? So what do we need to do? Put in parentheses. That's right. So you have 13abc all to the 1/2 power, because the 13abc is all inside the square root. Okay, so that's really the skill for today. Now, there is some that we need to simplify. That's what it says down here, simplify. Wow, that's weird. Anyway, how could we simplify? Well, you could actually get a calculator and in parentheses type in 1 divided by 16, close parentheses, and then do caret button, and then open parentheses and do the 1/4 power. Okay? Or you could manipulate the base. A lot of people like using the calculator. I like manipulating the base. So for example, 16. I know that 16 is 2 times 2 is 4 times 2 is 8 times 2 is 16. So I could rewrite this as 1 over 2 to the 4th power, because that's 16. And it's to the 1/4 power. And then I could change the 2 to the 4th and move it up. Now, why would I want to do that? Because I'd end up with 2 to the -4 up on top over 1, which you don't even need to write, to the 1/4 power. And when I multiply power to a power, I get -1. So my answer would be 2 to the -1, which later becomes 1/2 because you move it back down. Now, you don't have to do that. You could type it into the calculator like this, parenthesis 1 divided by 16, close parenthesis. Look for the caret button, because that'll be your exponent. Then you open parentheses and put 1 divided by 4, close parenthesis, and then hit equal, and that'll give you the same answer, 0.5 or 1/2. Question. Number 11, what would be nice to have in here? It would be nice to have a certain number to the power of 5. That way you could convert the 5th root to be the 1/5 power, right? So try with your calculator. Let's say maybe 3 to the 5th power. Maybe that'll give you 3,125. Maybe 4 to the 5th power, 5 to the 5th power. I don't know. I don't even have a calculator. Can somebody help me out here? So 5 to the 5th power is actually 3,125. So it's good to rewrite it that way. That way when you multiply 5 times 1/5, it cancels out and your answer is just 5.